which is enabling secure and effective biomedical data sharing through cyber infrastructure gateways. This is another recorded presentation by Tyler Phillips, and I know both Tyler and Shreya Goyal are on to answer questions at the end. So, Mike, please play the video.
Hi, I'm Tyler Phillips, and I'm here presenting with Shreya Goyal, and we're going over our paper enabling secure and effective biomedical data sharing through cyber infrastructure gateways. And we're from IUPUI, or Indiana University, Purdue University, Indianapolis, and Indianapolis, Indiana. So first, I'll go over the motivation and introduce our project. So the motivation of our project. So we have this JetStream cloud computing service funded by the NSF, and it's widely used by Indiana healthcare researchers to enhance collaborative research. So the type of data that they're dealing with there is, healthcare data related to like policemen and firefighters in the Indianapolis area. So although it's widely used, the JetStream security features do not satisfy the requirements involving sensitive healthcare data and protected health information. So this drives the need and motivation for securing the cyber infrastructures that JetStream uses through an easy-to-use, extensible, and robust cybersecurity architecture that can protect sensitive information being shared, for these scientific collaborations. So here I'll turn it over to Shreya to give us the introduction.
Okay, the aim of the Dynaswap project is to develop integrated and trustworthy holistic secure workflow protection architecture that for cyber infrastructure such as JetStream. The proposed cybersecurity architecture supports role and data hierarchies, as well as the dynamic changes of role and hierarchical relations within the scientific infrastructure. So now we'll provide an overview of our project. So currently, Dynaswap works on OpenMRS. OpenMRS is a community-developed open-source electronic medical record framework that is used for exchanging healthcare information. So this system is based on open standards such as HL7 for achieving interoperability with other systems while transferring or exchanging patient data. So as mentioned, currently Dynaswap project works with the OpenMRS database, but however in the future this can be applied to other databases. So the project runs on an OpenMRS image that is a template of virtual machine with pre-configured security techniques in it that will allow the users to securely access information stored in this database.
So in order to address our motivation of securing this OpenMRS image and allowing researchers to use it, we add some security components into the image, which then researchers can deploy through the JetStream tool. So some of the security components we embed into the OpenMRS image here is Biometric-Capsule-based privacy-preserving facial authentication, which we'll see, but it also includes two-factor authentication. We include dual-level key management, which is a cryptography-based hierarchical access control model. And we include secure digital provenance. So I'll go over each of these in detail later in the presentation. But again, these are the security components we're baking into the OpenMRS image.
Okay, so as mentioned earlier, JetStream is a cloud computing environment that is supported by NSF for collaborative research. So it is designed to allow the researchers to get access to various computing and data analysis resources. So JetStream allows the user to get access to virtual machine images pre-configured with an operating system and software that allows to do scientific computations in domain-specific tasks. So OpenMRS image will be built with all the security features and components implemented in it, so that when users will deploy a VM with our image, it will allow the users to remotely access and share sensitive data information to perform their research. So these are some of the steps on how we can deploy a JetStream VM using OpenMRS image. So first of all, you need to create your Exceed account. So once you create that, so it will ask you to enter your username and password. And once you are authenticated, you'll see this JetStream dashboard that allows you to launch a new instance of VM. So there you can click on the images options and then type our image, that is OpenMRS, and you'll see the OpenMRS base image. The latest version is 1.3, and then you can hit on the launch button that will allow you to deploy a VM with this image.
So now that we know, the overall architecture of the project, I'll talk about some of the security components that we're adding into the OpenMLS image that will allow researchers to collaborate, more easily and securely. So the first aspect is, in the current OpenMLS image, the only authentication method or scheme that you're allowed to use is regular username, password, login. But here we've added facial authentication. So due to the proliferation of biometric sensors and smart devices, biometric authentication has recently emerged as a promising solution to the loss, theft, and usability issue facing traditional authentication methods. So we talked to some nurses and healthcare, professionals in the Indianapolis area, and they said that within this OpenMLS, image, it'd be much more helpful to have, biometric authentication, which is more useful for them on the job. But one issue facing, biometric authentication is that, if your biometric template or, facial attributes are stolen, the feature vector which represents that, it's a lot hard to cancel and reset that, compared to how you would a password. So we need to secure those biometric templates used for the facial authentication. And that's where this Biometric-Capsule scheme from 2019 comes in. How it works is it fuses the biometrics, or that feature vector of the user, with a reference subject in order to conceal the user's biometrics. So if you look at the bottom here, this workflow, you'll notice that, you have the typical biometric pipeline here. You take a user signal, by taking a picture of them, you sample and pre-process that image, you extract features, and then you perform some classification. But you'll notice in the biometric pipeline here, it also includes that reference subject, or RS, workflow. So each user is assigned an RS, and each time the biometrics are sampled and used for authentication, the biometrics are fused with the biometrics of that reference subject to conceal that user's biometrics. So there's a few advantages of this. One, we can just make the RS determined based on the user's role within the organization. So then at authentication time, a user needs to only provide their username, provide their role within the organization to determine the RS, and then allow the picture to be taken to provide the facial biometrics to the system. And it should be noted, although we're using the secure facial authentication scheme here by fusing the biometrics, we still are able to leverage state-of-the-art deep learning technologies during this facial authentication. So if we think about next moving on to access control, data access control, or operation access control, with the sensitive healthcare data. In the existing scheme and in many, healthcare domains, organizations typically set up the access control policies, which users have access to which corresponding data based on a rule-based access control model. So the rule-based access control model is pretty straightforward. You just define which users have access to which data. But unfortunately, there's no security component that's baked into that role-based access control model. So there's nothing to, enforce your access control policies. So that's why we've upgraded the OpenMLS access control model to a cryptography-based access control model, where there's cryptographic keys given to each user or set of group of users, like nurses and doctors, to actually explicitly enforce those access control policies which we define. And it raises a few key issues, such as hierarchical model design, how to generate that model, and how to manage those cryptographic keys. So we use this 2019 IEEE TPS paper to carry that out. And what that ends up being, from the user's perspective in an OpenMLS image, is that, some manager or, admin within a hospital organization using this OpenMLS image can how perform a user-friendly or generate a user-friendly definition of different rules and the data object privileges to the left here. And then we have a model generation algorithm which automatically generates all the keys to generate that access control model and enforce those access policies which we define. So the last part of this, which is still ongoing, is we're adding a secure digital provenance component into the OpenMLS image. So this is based on a 2014 paper, and what this is sort of similar to is blockchain technology, if you're familiar with that. So users utilize several cryptographic primitives, including cryptographic hash functions, private public key cryptography schemes, and digital signatures in order to generate a hash chain. So what this hash chain does is it records the ownership of a digital object, that digital object's current state, and any modifications performed upon that digital object, as well as when a user is trying to access that digital object. So this will be valuable to integrate into the database component of the OpenMLS image, and this is an ongoing work, as I mentioned.
Okay, so next is a usability experiment. So once the Biocapsule authentication system was implemented, we did a usability testing to see how it works. So we asked the students from privacy and security course to perform some of the tasks which is mentioned in the next slide, and then send out a survey to them to answer questions regarding the 3 authentication methods used. So these were the tasks that the students were asked to perform. First is like logging into OpenMRS using 3 different authentication methods, that is the biometric facial authentication, single sign-on, and the username and password method. And then they were asked to perform some of this basic tasks like creating patient records and then logging in as provider, as patient with different access and all those things. Then these were the 5 variables on which the questions were based and asked, that is the efficiency and effectiveness, satisfaction, preference, concerns, and confidence for the 3 authentication methods. So once we got the results, we developed a formative partial least square structural equation modeling to measure the relationship between the usability and security. So from the results, it was found that the Biocapsule facial authentication was the most preferred, usable, and secure among the 3 authentication methods used. So this concludes that the Dynaswap project allows to build a secure, holistic, multi-layer protecting cybersecurity architecture that can be ported to multiple virtual machines on JetStream. It allows for scientific data so that researchers and students can remotely access and share protected data in a convenient yet finely controlled manner. Thank you.
Thank you.
Okay. Well, great. So I know both Tyler and Shreya are on, so feel free to unmute yourself. And anybody has any questions, you put them in group chat. I'll start by saying I think it's super cool that you all are reporting, actually you did, and reporting on a usability study, because I think that's one of the things that in the community we don't talk about enough, and I know we don't perform them enough because that's really important, the end usability. So I guess I'll just tee it up as to, is there anything else you want to say about the usability study? I don't know, maybe did you look at any type of digital accessibility type aspects of it or anything like that?
Yeah, so I think the main motivation is to give researchers some more flexibility in terms of the security components that they're using if they're using this OpenMLS image in the research. So we can add all the security components under the sun, but at the end of the day, it needs to be usable. So we have a couple different experiments underway, primarily led by Shreya here, but they're just getting feedback from students, and these students are both, taking our security courses at our university, as well as students studying, more things more on the healthcare side of things, so we can get both of those perspectives. So the advantage of the biometric, authentication that we found is, once you get it's kind of cumbersome at first, getting it all registered in the system with your face and stuff. But once you get past that initial point, a lot of people before that to the username and password, because, you know, most phones and smart devices nowadays have the, you know, the biometric sensor or embedded camera, you know, in them. So, you know, you have that flexibility to use that in a version of the image.
Great. We do have another question in chat, and is the data actually in the VM along with the tools?
So at this stage, we're just using fake data, you know, just to make sure, you know, all the tools are in place. But we're on the last year of this NSF CI/CI project. So now we're moving on to, you know, this experimental, more experimental phase past development, where we're getting this usability feedback, and that is, part of our plan over the next, final year of this project is to start trying to, integrate real data and see, how our intended audience, these researchers receive, our final product here.